Assalamu alaikum wa rahmatullah. Today we're gonna have another interesting class. It's basically gonna be a refresher of some of the concepts that we have already taken about desertification in the previous weeks, and it's gonna also build our understanding about desertification. So if we just do a quick revision of what we have covered from the beginning of the semester, we already know the definition of the desertification. We know the nature, the causes, and the impact of desertification. Then we studied about how to identify desertification, how to know that this land undergoes a desertification. And here we studied about the indicators. Then we saw the importance of studying even the processes that happens at the small scale, like the micro bores, and we studied these processes in details and we gave many examples about it. Then we even studied how human can impact these processes, and now we're gonna know something else. A lot of you might ask yourself a question that, okay, now I know that to be able to identify that this land undergoing desertification, I have to look at the indicators. But how can I judge that this land undergoes this much of desertification, or this much of the land is desertified? And this only can be determined by something called monitoring. So let's understand what is monitoring and how it works. To start, I'll give you an outline of what would be the lecture about. So this lecture would talk about two main points. At the beginning, we will give a brief, or we will go through a brief history about monitoring of desertification and how it developed, and then we would know what is really monitoring means. And then we're gonna study 4 different types of the monitoring and mapping techniques that would help us to identify the degree of desertification in an area. We're gonna know about the field monitoring, remote sensing, expert's opinion, and finally land user perspective. So let's start. The concept of monitoring of desertification goes back to 1970s, where desertification was first identified and discovered in the Sahel area in Africa. At that time, when desertification was first identified and they noticed that it's really a serious problem in Africa, they called for the United Nations Conference on Desertification. And in the conference, they concluded that around 3,970 million hectares of the Sahelian area is undergoing the effect of desertification. And this is really a huge area. It's about 4 times the size of Europe. But if we look critically at that particular time, we would see that the assessment method was lacking actually the national and the global scale. It means that the problem was only identified in Africa, and therefore the other people in the other countries did not know so much about it. And the monitoring and the assessment method was not systematic. It means it was just started without so much experience, without tools and many other things. And therefore, because of this, the area or the assessment technique was criticized by many scientists and people. The criticism of the previous estimate initiated another program by the scientists, basically after a few years, specifically in 1987. And at this time, the United Nations Environment Program initiated another program and another assessment called Global Assessment of Human-Induced Soil Degradation. Well, basically what they did, they redo the estimation of the amount of area that is desertified in the Sahelian desert. And this time, the assessment was based on the experts' opinion. So what they do, they ask around 250 soil scientists and environmental scientists from over 21 regions in the world to come to the Sahelian area and redo the estimation. And at this time, the aim was not only to identify the desertified area, but even to come up with the more specific information, like what is the type of desertification that exists there? Is it a vegetation type? Is it because of, let's say, because of the overgrazing, because of the drought? What exactly the causes of the land degradation over there, and at what rate, and so on and so on and so on. So at the end of the day, they concluded that the previous estimate, which was 3,970 million hectare, was overestimated. It means that the real size of the desertified area is basically about 3 times less than the previous estimated. Even though this estimation was based on expert opinion, it was again criticized. Well, scientists, people, they don't stop criticism. They always have something to say. Why it was criticized? Because of the following reasons. If you go back to the definition of desertification, you will find at the end of the day that when you talk about human causes, it has to consider the 3 sustainability pillars: the socio-economic, the political things, and the environmental factors. So this assessment by the scientist or by the expert was criticized because it did not take in consideration all the 3 aspects that is in the definition. It doesn't take the management goal. It does not involve the local stakeholders. It doesn't involve people. It didn't ask them and so on. And it only provide information about desertification, only about the environmental aspect, and specifically only about the soil. That's why it was criticized. We can see from the previous discussion that to come up with a precise estimate of the extent or the area that undergoes desertification, you would have to consider all the sustainability pillars. Remember that when we talk about the definition of desertification, it's a type of land degradation due to climatic changes and also human impact. And we talk about human impact, we have to consider the 3 sustainability pillars: the socio-economic, the political, the institutional, and the environmental factors. If you did not consider all of these aspects, you would have incomplete and not precise estimate of desertification, like what we said in the previous slides. The second thing that you have to keep in mind, that if you just look at the map here, you would see that this map actually classified the countries of the world based on their vulnerability to desertification. Some of the areas are highly vulnerable. They are more susceptible to desertification. Little changes or little impact can really cause desertification, and some other countries are resistant. But to come up with such a map, and to come up with a map that identified the desertified area, you need basically to look at something that would tell you desertification, or would tell you the desertification, and that is basically the indicators. For example, to tell whether a land is undergoing desertification or not, you can look at their vegetation cover. So by monitoring, by collecting information about the vegetation status, the vegetation density, the changes in the vegetation, and so on, you would need to monitor the vegetation in that area for a long time and collect all of these information, and then you would see whether the vegetation cover is gone, and if it is gone, is it recoverable, like after some time it again recovers, so this won't be desertification, or the vegetation cover is not going back to its original status. And here you would say that, yeah, it's a land degradation. Yeah, it is as a desertification. So remember, always for monitoring, you need to look at the indicators. And there are basically 4 different techniques to do the monitoring, or to get the desertification into a temporal and spatial scale. Spatial scale, we mean over the area, over different places. And the temporal scale, it means over the time, the changes over the time. So we can use field monitoring, secondly, remote sensing, third, expert's opinion, and fourth, land user perspective. So let us start to know each one of these techniques, and let us start with the field monitoring. To do the field monitoring, you need human and you need instrument. So since basically it's in the field, so you go to the field with your instrument, and then you look at indicators, and then you would start collecting information about that indicator. For example, you can identify the climate factors like the temperature, like the rainfall, the solar radiation, and so on, using some of the instrument. For example, you can collect information about the rainfall variation and the rainfall intensity using rain gauge. Like you would see in these pictures here, you have weather station. You can collect about the temperature. You can collect about the solar radiation using the weather station. You can also get information about the soil compaction by using the bulk density sampler. You can also get an information about how fast the water moves inside the soil, and that would tell you whether water is actually going to be going into the soil or running over the surface. And if it's going on, and if it is running over the surface, then it will cause erosion, and you know what erosion can do when it comes to desertification. So to monitor the infiltration, or how fast the water moves into the soil, you use a double ring infiltrometer. And here you need the human also to collect the data and to stay in the field and monitor this one. You can also know, for example, about the vegetation density. And here you would bring a plot, and then you can calculate the number of plants and the density of this plant cover inside that block. And you can also know an information about the groundwater, the depth of groundwater, and then you can know whether this groundwater is now depleted or not. Or you can know the quality of the groundwater using the piezometer. So you would use these instruments with the help of an expert, a human, to stay in the field and collect the information. However, sometimes you can collect this information automatically. If you look at the weather station, it has a data logger. So it's a data logger is a system that actually store all the information in the memory. So you don't have to go every day into the field. Just for example, go to the field once in a month or once in 6 months, and then you just download the information, and then you have to analyze them and to look at the data. Or sometimes even the technology allows that the weather station by itself can send the information to your computer, and then you will have to work it out and then use your experience to analyze this data and to extract the most important information that would tell you about desertification or the extent of desertification. So this is basically how the field monitoring can be done. Now you would ask yourself a question: is field monitoring the best method among the other 3 methods? Well, the answer to that, we have to look at the advantages and the disadvantages. Now, if we start just with the advantages, you would see that with the field monitoring, it's really a very precise one. Why? Because you would go to the field and you can monitor each one of the indicators using a specific instrument, and you will collect information, enough information with time about that particular indicator. So that's why it's one, precise, and then you collect various information about it. Secondly, since you use human, then you can quantify even the other sustainability pillars, not only the environmental impact, like monitoring the vegetation or the soil or the climate and so on, but you can monitor also and you can know the socio-economic features, for example, like the population, the movement of people, the living standard. And here you can do it by having the questionnaire. So for example, you would go into the field and you would start distributing questionnaires or interviewing people and collecting information about this. You can also evaluate the public perception. Since you are going into the field, you can ask people, well, what do you know about this problem? Do you feel it's a problem? And then you can identify their perception, whether the people believe it's really a serious problem or just like a normal thing that happens in their daily life. And you can also discuss with them whether the solutions that you are thinking of might be or might work for them or not. And this would enhance the public acceptance, so it will tell you whether people would accept your solution or not. The only disadvantage with this method that since you use a lot of instruments, it's really costly. For example, I'll just give you a glance. Just if you look at that soil sampler for the bulk density, its price of an original instrument can reach up to 50 riyals. So imagine just that normal instrument is 50 riyals. Sometimes you can buy a sensor by, for example, 100 riyal. And we are using, for example, another instrument to scan the moisture content in the soil with the depth. And you know the price of that instrument? 3,000 Oman Riyal. So you'd see one device only or one instrument can be really, really costly. But it's worth it sometimes. It's worth it because it gives you very precise information. Now let's move to the other technique. The other technique is remote sensing. And basically, the difference between field monitoring and remote sensing is very clear. Remote sensing is to collect information without being in the field or having a physical contact with the indicator. For example, you can collect information about the vegetation, distribution and intensity with time using the images that captured by the satellites for even like 60 years. You just sit in the computer, get those images, and then start analyzing and working them out. So this is one of the advantage of it. Like you can collect a lot of information without going into the field, without the need of so many instruments, because you would use the remote sensing instruments, like for example like the satellites or like the sensors which are hanged in plane or in a drone, and then you will collect this information of the reflection. The disadvantage, and you can cover of course a wide area, you can collect a lot of maps just like in a simple way. The disadvantage of this one, that basically when you do remote sensing, you are not exactly collecting information about the indicator. You are using a satellite, and this satellite, for example, sends waves, and then the reflected waves, you would analyze them. For example, if you are monitoring vegetation as an indicator using the satellites, then vegetation has a specific reflection. يعني كأنكم تقولوا بأنه الرeflection مال الفيجيتيشن تكون في هذا الويف لينث بس، مثل مثلا اما مثلا لما تكون التربه وحدها ما فيها فيجيتيشن الويف لينث مالها كذا، الماي الويف لينث ماله كذا، فكل واحد منها الا ويف لينث معين. فانتم في الحقيقه ما مجمعين بيانات علات الفيجيتيشن مثل لما تروحوا في الفيلد ويعني تحسبوا الفيجيتيشن صح، يعني نفسها you are collecting information about the reflection. وبعدين عشان توجدوا يعني ال amount of the vegetation exactly the exact amount of the vegetation, you would have to do correlation. يعني لازم تسوي جرافات فيهن علاقة ما بين الويف لينث هذه وما بين الفيجيتيشن density الحقيقية. By this you have to go into the field, collect information about the vegetation, and then you can do the validation and verification, and then you would get these correlation graph, and then you can analyze the maps.